Lesson 12.1 Exponential Functions continues. In this video, we will write exponential functions to represent geometric sequences and evaluate each function for a given n. On the way to work this morning, I got into an argument with an angle. It was right. Write an exponential function to represent each geometric sequence. Evaluate the function for the given values of n. Round to the nearest thousandths if necessary. Alright, so number 7. A sub n equals 4 times 2.5 to the n minus 1. And then when we're done, we will evaluate it for n equals 10. So the process I like to use for this is a process called split, flip, multiply. So what we're going to do is, at least the first thing we're going to do is we're going to split that exponent up. So we can take 2.5 to the n times 2.5 to the negative 1. Because we know that if the bases are the same and we're multiplying, we add the exponents. So we would take n plus negative 1 or just n minus 1. So we're just sort of splitting it up. Second thing is flip. A sub n. Okay, so we can turn that negative 1 into 1 over 2 to the 5th, because we know a negative exponent means to flip the fraction. And then on the next step, we're going to replace a sub n with f of x, which also means our n is going to become an x. And we're going to multiply the terms that do not have an n with it. So 4 times the 1 over 2.5, or just 4 over 2.5, times 2.5 to the x. Okay, we can also stick 4 over 2.5 in a calculator and get 1.6. And then we want to evaluate it for n equals 10. So we have f of 10 equals 1.6 times 2.5 to the 10th power. We can stick that in our calculator and we get f of 10 equals 15,258 point, they want 3 decimals, so 789. And that's how we write explicit functions in our exponential functions to represent geometric sequences. What I'd like you to do now is pause it, try number 8, and then unpause it and check to see how you did. So hopefully you first split the exponent and got 8 to the n times 8 to the negative 1. Then flipped the 8 to be 1 over 8. And then multiplied the 0.03 times the 1/8 and got 0.03 over 8. And then wrote out your function, which is f of x equals 0.0375 times 8 to the x. And then we plug in 3 because that's what n is, and we get 19.2. And with that, that's how you write exponential functions to represent geometric sequences. And then evaluate a given value of n and round it to the nearest thousandths place.